Everyone, welcome to today's video. We are going to solve decimal equivalent of binary linked list. So in this question, we are given linked list of n number of nodes, okay, and n is not given, but all the nodes of linked list are of binary digits, are fulfilled with binary digits, and we have to represent its decimal representation. So see, in example 2, you will be able to clearly understand. There are four nodes, okay, and here's a decimal representation of all the numbers. See, the last number 0, you multiplied it with 2 to the power 0, which is 1 into 0, 0. Okay, then 1, second last digit, 1 into 2 is power 1. 2 raised to the power 1 is 2, 1 into 2, 2. Similarly, 4 into 1 and 8 into 1. Okay, now these are the summations. This is pretty simple and straightforward question. You can solve this question using bit masking and all, but I'll be using a very simple method. I'll be using list. Okay, I'll just use and create an empty list, and will transform all the nodes of the linked list in this linked list. Okay, well, I dot append like my empty list head dot data. While there are nodes, while there are nodes, you can use temp variable for it, but there's no need because we do not need anything fancy over here. I'm just saying, as far as there are nodes in the linked list, just append its value in the list. Okay, and at this point, okay, what one next thing, we'll have to forward our node to the next node. Cool. Now at the end, I'll just store length of list. This will give us the length of nodes which are there in the linked list, because in the example we are shown that n is equal to 3, n equals to 4, but we are not given value of n as an argument in this question. Okay, now next operation, just a single loop for I in range n. N is our length of list, length number of nodes. Okay, now res was there to store the result. Cool. Now there's one thing. See the explanation. What are these zero? This zero is the node of linked list. This one is again node of linked list. Then one again is again the node of linked list. So one thing is for sure, we need that this particular the ith particular list element, node element. Okay. Now we are multiplying it with the 2 raised to the power index value, and we are using zero based index. We are using zero based index. So we are multiplying the ith value of list or node linked list, okay, with the ith with the ith value of what? Ith value of 2 raised to the power, which is, this is how we convert into decimal representation. Okay. Now we will multiply it with 2, but 2 raised to the power n minus I minus 1. Why? N minus I minus 1 will give us the current value, because we are using zero base index, and this n minus I minus n minus I will give the current value, the current index which we currently are at, and this minus 1 will yield us the current value, because we are using zero based indexing. And at the end, we'll just return value of our result. This will do the job. Let me submit it. Okay. Okay, we have to just mod the result. As you can see, it is able to do the job pretty effortlessly. It is taking some time because we are using order of n, and we are allowed to use order of n in the time complexity given in this question statement. Okay, yeah, it did solve. It took some time because we are using order of n, and there can be large number of nodes. That is why it took some time. But at the end, we are able to succeed. So I hope you enjoyed it. Thank you. Have a nice day.